Today we will understand cell sorting algorithm. This is most efficient sorting algorithm among many other algorithms which have order of n square running time. So we can write this is most efficient algorithm among O n square class of algorithms. We have several algorithms which have order of n square running time. Many algorithms have this order of running time in average case and worst case, and some other algorithms have this order of n square time in worst case only. So the algorithms like bubble sort, insertion sort, selection sort have order of n square running time in worst and average case both. And other algorithms like quick sort and heap sort have this order of time in worst case only. So our cell sort algorithm is most efficient algorithm among all these algorithms. This has approximately running time of order of n to the power 3 by 2, which is equal to order of n to the power 1.5, which is less than n square. So this is most efficient algorithm among this class of algorithm. This algorithm is also called diminishing increment sort algorithm. Diminishing increment sort. We have also studied some other increment sort algorithm, and these increment sort algorithm actually are called increment sort algorithm because they sort the element one after another, pass by pass. Like in bubble sort, in each pass we one element gets its final position, in next pass another element gets its final algorithm. So they solve the problem in incremental way. So these are called incremental sort algorithm. Cell sort algorithm is also called combo sort algorithm. This cell sort algorithm in each pass actually sorts the number which are at equal distance. In each pass, it sorts the numbers which are equally distanced. Equally distanced, that is, it compares numbers which are d distance apart. We can understand this, what is equally distance apart. Like in bubble sort, take an example 5 4 3 2 1. In bubble sort we compare the consecutive numbers of the array. Like first we compare 5 with 4, then 4 with 3, then 3 with 2, then 2 with 1. But in case of cell sort algorithm, we compare the elements which are at d distance apart. Suppose if d equal to 3, then we will first compare 5 with 2, then 4 with 1 likewise. So this compares the elements which are at d distance. Also, in each pass the value of d is reduced to half. So we can also write this: in each pass value of d is reduced to half, and this is calculated from this formula di plus 1, that is current value of d, that is next value of d. Di plus 1 is next value of d, is calculated based on current value of d, which is di plus 1 divided by 2. Suppose currently d is 3, then for the next pass we will calculate 3 plus 1 by 2, that is 2. This will be the distance for the next pass. And this algorithm terminates when d equal to 1. So termination condition for this is at d equal to 1. Note that at d equal to 1, we first run the algorithm. When the value of d is first time 1, then we run the algorithm. Then after this pass, we terminate the algorithm. Run the algo for d equal to 1, then terminate. We will not terminate for d equal to, that is we must run one time for d equal to 1, and next time we will terminate. Now let us understand this whole procedure with the help of an example. So let us take values 15, 9, 2, 20, 5, 35 and 45. We want to sort these numbers in ascending order. So first we will represent these values in the form of array, and before that we must note one more thing, that output of one pass becomes the input for next pass. And here the number of values are 3, 3, 6 plus 1, that is 7. Number of values in the array are 7. So before starting the algorithm, we must calculate the distance for pass 1. So we are giving name it to d1, and which will be equal to n by 2, and this is equal to 7 by 2, and performing integer division, this value comes 3. So we will compare the elements which are 3 distance apart. So first we will represent these values in the form of array. So this is 15, 9, 2, 20, then 5, then 35 and 45. This is our original array, and pass 1 is starting. So first we will compare. We will make another diagram where we will show that which values we are comparing. So this is 15, 9, 2, 20, then 5, 35 and 45. So first we will compare 15 with the value which is 3 distance apart. That is, we will compare 15 with 20. And because we want to arrange these numbers in ascending order, so we will check the condition if 15 is greater than 20. So if it is greater, then we will swap these values. But in this case, condition is false, that is we will not swap it. And this becomes input for the next iteration. So this is 15, 9, then 2, 25, 35 and 45. Now next time we will compare this time 9 with 5. This is 3 distance away, 1, 2, 3. So 9 is greater than 5. So this is greater, condition is true. So we will swap these values. So make another diagram where we will swap the values. So this is 15. Here 5 and 9 will be swapped. So 5 will come here and 2, 20, here 9 will come, then 35 and 45. Now we will compare 2 with 35, 3 distance away. So 2 is less than 35, so no swapping will be done. And next time we will compare 20 with 45. So this is 15, 5, 2, this is 29, 35 and 45, and we will compare 20 with 45. So 20 is less than 45, no swapping is required. So final array after pass 1 is 15, then 5, then 2, then 20, then 9, 35 and 45. Now we will start pass second. So pass second, we will draw another diagram, and before that we will calculate new value of D. So here we can calculate new value of D. Pass 2 is starting here, and we will calculate D2 distance that we will use in pass 2, and this will be D1 plus 1 divided by 2. So D1 is 3, so 3 plus 1 divided by 2, and this will come out to be 2. Now this time we will compare the values which are 2 distance apart. So we can draw this diagram here. So first value is 15, then 5, then 2, 20, 9, 35 and 45. This is pass 2 is started. So this time we will compare first value with the value which is 2 distance apart. So we will compare 15 with 2. 15 is greater than 2, so we will swap these values. So this will come here, 2 will come, 5, and after swapping 15 will come here, then 20, then 9, then 35 and 45. Next we will compare 5 with 20. Because 5 is less than 20, not greater than 20, so we will not do the swapping. Rather, elements will remain as it is. 29, 35 and 45. Now we will compare 15 with 9 because 15 is greater than 9, so we will swap these values. 2, 5, here 9 will come, then 20, here 15 will come, then 35 and 45. We will next compare 20 with 35. We'll keep on increasing till we have the values. So 20 is less than 35, so no swapping is required. And next we will compare 15 with 45. So here 2, 5, 9, then 20, 15, 35 and 45. Now this time we will compare 15 with 45. So 15 is less than 45, so there will be no change. That is 2, 5, 9, 20, 15, 35 and 45. Now we will not compare next values because if we increment this by 1 and we want to compare 35, then we are not getting any value in the array. Now for next pass 3, this will become the input, and before that we will calculate new value of d, which is equal to d3, and this will be d2 plus 1 by 2, and this is equal to 2 plus 1 by 2, and which is equal to 3 by 2 equal to 1. So here now we got d equal to 1. So for this d equal to 1, we will run the algorithm once, then we will terminate it. So two, 5, 9, then 20, 15, 35 and 45. This time d is 1, so we will compare the elements which are one distance apart. So first we will compare 2 with 5 because 2 is less than 5, so no swapping is required. Now next we will compare 2, 5, 9. First copy these values, 20, 15, 35 and 45, and next we will compare 5 with 9 because 5 is less than 9, so no swapping is required this time also. Now next first we copy the element, that is here, two, then 5, then 9, then 20, 15, 35 and 45, and next we will compare 9 with 20 because 9 is less than 20, so again no swapping. Now first in this, because this is diagram, so we have to copy these elements, otherwise in programming the elements are stored as it is. We have to just increment the value of I for the next comparison, 20, then 15, then 35 and 45, and this time we will compare 20 with 15 because 20 is greater than 15. So with this time we will swap. So 2, 5, 9, and because 20 is swapped with 15, so 15 will come here, then 20, then 35 and 45. Next we will compare, because we have compared the element which is at this position, so we will increment the I and we will compare the element with 20 with 35. See here, the I, this is I, and it is increasing one by one because D equal to 1. Because here also 20 is less than 35, no swapping is required. So first copy the element in this diagram. So this is 2, 5, 9, 15, 20, 35 and 45. Now compare the element 35 with 45. Because 35 is less than 45, so no swapping will be done and we will get the final array 9, 15, 20, 35 and 45. And this is, we got the sorted array. So after in this case, after 3 passes, we have sorted this array set of values in ascending order. Now on the basis of procedure that we have used, we will design the algorithm for this. So now we will write the cell sort algorithm. So we will write the procedure here, cell sort, and here we are taking array in the input for this procedure, and this array can have any data type, so we are not writing the data type here, and we will write the number of element here, integer type n. This must be integer, number of values in this array must be integer. So according to the procedure that we have used to sort the values, first we are calculating the value of d. So we will write d is equal to n by 2, and we will take the floor value of this. Next we have to run the algorithm till the value of d is greater than equal to 1. So we can use one loop here for this which will control the pass, that is d is greater than equal to 1. Then for this each pass we are seeing that we are comparing the values which are at d distance away. So for that we will use a loop for I equal to 0 we can write, or we can start from 1 here, 0 to n minus d minus 1. Now if element ai is greater than element ai plus d distance away. So we will add D here. If AI is greater than AI plus D, then we have to swap these two values. So using the indentation, we will write the statement inside if after leaving some space. So T is equal to AI, then T is temporary variable, AI is equal to AI plus 1, and then AI plus 1 is equal to T. Now after this loop is run, then we will check the value of D. If D is equal to 1, then return the procedure. Otherwise, this is not otherwise, we have only one statement, then we will calculate the new value of D, which is equal to D plus 1, and this is integer division by 2. So this is our algorithm. So we will put line number here 1, 2, 3, this is 4, T is equal to AG is line number 5, is equal to 6, 7, 8, and this is 9. Now see here, by taking the previous example, first time D was 3. So 3 was greater than 1 in our previous example. It was 3, so 3 was greater than equal to 1. So we will come here and we will compare the values, that is first value with the value which is 0 plus 3, that is D distance away, that is A0 will be compared with A3 element. Then I will be incremented by 1 and we will compare all the values. If this is greater, then we will swap the values. All these three statements are one below another. This is at the same distance from the left indentation. And if D is greater than 1, then we will return, and this we are calculating D value inside while loop. And see here, this 3, first time the value of D was 3, so 3 plus 1 is equal to 4 by 2, and this will come out to be 2. So 2 is greater than 1, yes, we will come again inside the loop, and D is not 1, so we will calculate new value of D. This time D is 2, so 2 plus 1, that is 3 by 2, and we will get 1. So at D equal to 1, we are true, that is D1 is greater than equal to 1. So we are running the algorithm once. When this time D is 1, so our algorithm will terminate. Pause. Now we can calculate the complexity of this algorithm. Here we will write the cost of execution of each statement, and here we will write the number of times each statement is executing, number of times each statement is executing. So suppose cost of this is C1, this is C2, this is C3, C4, C5, C6, C7, C8 and C9. So we can clearly see that this statement will execute only one time. This will execute D. So how many times this will execute? This will execute log n times, because each time, suppose n is 128, so next time n will be 64, next time it will be half, because we have said earlier that the value of n will be half in after each pass. So this will be 32, then 16, then 8, then 4 to 1. So this is coming out to be log n. So this statement will execute log of n base 2 and plus 1 times. 1 times for false value and log n times for true values. And all the statements which are inside this will execute depending on this. This for loop will execute depending on the value of d. So suppose d is equal to n by 2 first time, d is equal to n by 2. So this will execute n minus n by 2 minus 1 plus 1, because it is executing from 0. So this will execute how many times? N minus approximately n by 2 times. We actually write here number of times the statement is executing for whole run of the algorithm. So this will be for first time n is equal to n, first time it will execute for n minus n by 2 times. Next time it will execute for n minus n by 4 times. Then it will execute for n minus n by 8 times. Then at last it will execute n minus that is last time it will execute 1 times. Now this will execute n minus 1 times, n minus 2 times, or in summary we can write that this will execute, this is equivalent to n minus sigma I is equal to 1 to, this will be log n base 2. That is, this value d will come this number of times, n minus log n base 2. This will, d will be reduce these number of times, log n base 2 times, because we have seen this here. So this will log n base 2 times, and this n is, we can see here, it is divided by 2 to the power I. Next, this statement, if statement will execute, suppose this time is equal to x, so this will execute 1 less than this. So this will execute x minus 1, x minus 1. Suppose condition is true for each case, we are calculating for worst case, so this will also execute x minus 1 time, x minus 1 times, and this will execute how many times? The number of times this statement is executing will execute 1 less than this. So this will execute log n base 2 times, and this will also execute log n base 2 times. Now if we calculate this expression, so we can see this will come out to be, we are taking common from this here, n, and how many terms are these? These are log n base 2 terms. So this n is multiplied by log n base 2 times minus, we are taking from second part we are taking n common, so minus n, and this will come out to be 1 by 2 plus 1 by 4 plus 1 by 8, and at last we will see that here 1 will come, here 2 will come, here 4 will come. So we have to calculate this, and we can write this in reverse order: 1 plus 2 plus 4 plus how many times? Log n base 2 terms are there. So this will come out to be, this is GP, so this will come out to be n log n base 2 minus 2 to the power log n base 2 minus 1, a into r to the power n minus 1 divided by r minus 1. So this is the running time of this algorithm. Although we have several calculations we have seen, and there the running time is coming for this is coming out to be order of n to the power approximately 3 by 2, but actual time is this. So this is, that's all for cell sort algorithm.